Hi everyone! Today we're going to talk about multi-line drawings and orthographic projection and some various drawing components. So let's get started, shall we? So we are going to learn about how to create multi-view drawings using orthographic projection. And last week we discussed a little bit about line, lettering, and scale. Remember line quality. There are different things about lines that you need to know, the different types of lines, and that lines have different heavinesses, thicknesses, meaning weights, and lightness and darkness. And that's dictated by your lead, the strength of your lead, the hardness or softness of your lead, and also the thickness of a line has to do with your mechanical pencil and the thickness of that pencil itself. Is it a 0.5, a 0.2, a 1.0? We also touched base about architectural lettering and the importance of architectural lettering and scale. Everything has to be in scale. Architectural drawings are very thorough, and so learning to master that scale and also converting inches into feet in inches and vice versa is very important. Remember, when we're doing drawings, we always put feet and inches when we're dimensioning. Very important to be accurate. So using that scale and really mastering that tool is important. And creating those very precise documents require excellent line quality and professionalism, which is seen in your architectural lettering. So that was last week. Now we're going to talk about multi-line drawings, how to actually create drawings in architectural drawings. And so we'll get started on the basis of orthographic projection. Here's a few of the vocab words we'll be tossing around. The medium that we use to draw with, picture planes, and this word projectors and projector rules. Oblique projections, pictorial categories. We're going to talk about orthographic projection a lot. Paraline projections and multi-view drawings. This is what we're focusing on and the different types. We'll also talk a little bit about paraline drawings, which include isometrics and oblique drawings. So let's get started. Architectural drawing systems, what they consist of. So creating a multi-view drawings using orthographic projection. Now, we are going to do a little assignments on this in class and also as in one of the assignments. So as I go through this, keep your questions and write them down. This can be a little confusing, but hopefully I'll be able to explain it in the clearest way I know how. So orthographic projections is a means by which you take a 3D object and you're trying to translate it into a 2D drawing. Here's just a 2D drawing, it's flat. And so we're trying to create the illusion of 3D by visualizing all the other sides of this drawing. So how we do that, we use using our projection planes, okay? So project or transfer image to a picture plane. This is what we're trying to do. So orthographic projection, this is a method used to project an image in a different view, like a projector, like in a movie theater. So we're projecting an image in different locations. And how you do that, we're trying to see what does this image look like over here, and what is this one, and what is this one. So let's get started. See how these arrows are going each way? Those will represent our projection lines. So let's get started. So when you're ready to start a drawing, the first thing you do in a multi-view drawing is that you have a drawing medium, and that's just another fancy word for a paper. In our case, we are using vellum. Vellum is the most common, it's excellent quality, right? And this is what we use as our medium. And you can, in AutoCAD, they use regular bond paper that gets printed out. But in our case, we use that as our medium. Now, that is another word, the actual medium, the piece of paper, is actually the picture plane. What that stands for is the area you can draw on. That's the picture plane. Now, picture plane also has to take in consideration the title block all around it. So you wouldn't start putting a picture on or drawing on this piece of paper and going from edge to edge. You first need to create the correct title block with all of the information. So now suddenly my picture plane has gotten a little smaller here. So now we're dealing with picture plane that's just right here. So all of the negative space that you have on this drawing minus all of the information, that becomes your picture plane. And it's all on the drawing medium, the vellum. The vellum goes from one end to the other, but that doesn't necessarily mean I can draw on this whole piece of paper. I have to add all this information first. Then I have my picture plane. So it's the leftovers. So we all start with the picture plane. This is why it's really important when we start off with our vellum. As we lay out our drawing, we will create a title block. Then what's ever left over, we will be putting our floor plans on there. This is why we will be blocking out, meaning we're going to be putting a rough draft on a piece of flimsy or tracing paper, and so we could fit it correctly on the space we have to draw in, called a picture plane. If you just start drawing right away, you might be off-centered and you don't want to erase your drawing. So the picture plane is important to know its boundaries once all the information is on there at the title block, and to be able to pre-do a drawing, a little kind of rough sketch or block out, and we place it onto our beautiful picture plane, and we're able to move it exactly where it needs to go. So picture planes are important to know their boundaries. Next, we will take a look at the orthographic projection. So projectors are basically the lines or parallel lines that are parallel to each other. They're the lines that project out from the drawing. So that's basically what we call projectors. You know, if you had a projector right here, this was the film, it would project an image out here. That is what we're trying to do. We're trying to create, how do we draw these lines forward to mirror this image, what's going on this wall? So these projectors are parallel to the picture plane or perpendicular. We go both ways. We project one way and we project the other way. We're trying to create an image out of just this information. How do we do that? This is a fantastic shortcut for drafting. So imagine a multi-view drawing. That's what we call our drawings. Our drawings in architecturals are called multi-view. They consist of a plan view, which is really the horizontal version, like looking down or up at something. The section, which is basically something cut in half. Like imagine a piece of cake. You can see all the layers inside. And then the elevation drawings, which are one room or one side of any particular wall. So those are what we call multi-view drawings. They're plan drawings, section drawings, and elevation drawings. That is what we call that system. Now, we use orthographic projection to create other views. So if you just had this little side of a house, imagine that's the side of a house. We project these lines forward. You see how they're going forward? And the little roof line. But we have to know other information, like how wide this is. The moment you know how wide this is, you're able to stop and create what's called a plan view. So that's like looking on top of the roof. Now, if I want to create a side view of the house, what's going on down here? I project these lines over here horizontally. And now I'm creating a roof line, a side of a wall, and I take this information of how deep this is, and I know how deep this is, and now I can create the side of this house. So in a multi-view drawing, orthographic projection, we first start off with a plan view. A plan view is a bird's eye view looking down or up. So if I were looking at this, my home, and I cut it horizontally and was a bird looking down, that would be a plan view. Now, if I were also laying on my back on my floor, staring at the ceiling, that's another plan view of looking up. I don't see anything else but the walls. I just see the ceiling, and that becomes a plan view. Wherever the walls connect to it, that's all I see. It's like it's been sliced and I'm looking up horizontally, or sliced and I'm looking down. That is a plan view. Okay, so we start off with the plan view, and usually when you're going to be doing AutoCAD computer drafting, this is where you're really going to use this concept. You're able to extend lines very fluently and easily to create other views. So you are using projector lines, orthographic projection, to create another view. So let's go to that, shall we? So we start off with this situation. Right now, I am looking at a plan view of a floor plan. But now I'm laying on the ground staring up at the ceiling, and this is what we call a ceiling plan. So like I said, a plan view, you're either looking down or you're looking up. But all you're seeing is, you don't see the walls, the vertical walls, you're seeing the ceiling or the floor. Now, when we talk about another type of multiple view drawing, we'll talk about elevations. Those are the vertical view of the drawing. So now I'm tilting the drawing up and I'm staring at the walls. Each of these, this last plan view right here has 4 walls on each side. As we look at the front of the house right here, I believe it's right here, we can look at the front of this house. It's got a window, a door, and a window. So we use orthographic projection to create these elevations. So these show us the multi-view of this home. Next, another multi-view drawing is called a section. So this is like I vertically sliced through the whole home, that elevation, and I can see an X-ray view of exactly what's going on. This is called a section. Now, in a section, often you'll see things like that you would not see in visual life, it's almost like an X-ray. Here, I'm also seeing the slab of the house and the footings right here. Now, last week I had you do these little hatches. So you see them right here in this section. That little hatch down here represents earth. Over here, those little speckles and triangles represent concrete. This is showing me that this is the concrete foundation, and underneath are big footings that are pushed in, they're filled in, and that is the earth. Here we showed our brick pattern that I had you all practice, and up here is a wood grain, another hatch that you all worked on. So this is a section view of a multi-view drawing. So as we look at multi-view drawings using orthographic projection, what you're doing is extending the lines from the plan to create another view. So you see, I have this elevation of the front, this elevation of the side, and a plan view. You could either draw the lines down or up, but in this case, we project these lines up on each side. We know the little point, the gable of the roof, that's the point of the roof. And we need to have the information, what's the length between here and here? Once we know that information, we're able to create the roof. So if I were a birdie, I would be flying. This is what I would see on the top of the roof. Now, if I take those same type of lines and I project them over here to the right, and I have the roof line, and I know how wide it is because it's right here, I now created a side elevation. That is orthographic projection, taking one viewpoint and creating multi-views. So, what do you need to know? Well, you need to know when you're doing an elevation, if I started off with this plan view, how could I create this view? I can certainly just draw the lines, but if I don't know the height between this highest point and this lowest point, I can't draw an accurate elevation. So you must have additional information. So once you have this height, I am able to draw these lines, find out that this is 8 feet. I found out this goes to 12 feet and back to 8 feet. Now I have created a perfect side elevation. The same goes with this. As I project this way, I need to know, okay, how wide is it? Well, I know because we have that dimension right here. So we measure that, and that gives us this measurement. That gives us how wide it is. So you always need an additional information to create a very fluent and accurate projection. So you can't just do the lines without knowing pertinent information. Usually it's ceiling heights. Also, we can find out where windows are on a plan view, but we need information. How high are the windows and how far are they from the ground? That type of information is usually given to you by the architect, or you scale the drawing, but you can't complete the orthographic projection without certain elements and information with that. So let's check this out. And now, as you see here, we are looking at creating an elevation view using orthographic projection. It's also subjective. Where am I looking? If I'm standing out here looking at the outside of the house, I'm trying to interpret this information. What I see from here is, if I were looking this way at the house, I know there's a front door, there's some type of window here, another window here, and some kind of pop-out window here. So as we project all the lines across, see the door, the little window, the side jag, the outside, you're projecting all your lines, you're able to create some of the key architectural components. However, you still need information. You need to know, yeah, I see a window, but how high is it above the floor? And how tall is the window? That does not tell me. It only gives me an indication that there's a window. The same with the door. Now, standard doors are 7 feet, so we can usually pretty much guesstimate that. We know what way it opens, and this little triangle where it comes to a point shows us where the hinge is. Here's a little doorknob, so it opens a certain way. Next, we have this window. And we know there's a little window here. We just don't know how high it is from the ground and how tall it is. So that's, and this particular window, I would have never known that it sits completely on the floor. But that is what you need to make this lovely elevation. Same goes with this side of the house. It looks like I have a big picture window and a little window here, but who really knows? So as I pull the lines, I pull out this patio, I pull these lines across, pull out that patio over here, and I have pertinent information like how high this is, how high this window sits from the floor, and how tall it is. All of that information will help me to determine what this side of the house looks like. This is orthographic projection. Now I am creating an exterior view. Now, if I'm looking from the inside of the house, I project the lines the opposite way, and we'll take a look at that next. So make sure you know what view you're looking at so that you know how to accurately project the lines and create the look you want. So if I were standing outside of this house right here, I would be looking at this. That's what this represents. If I were standing here and I'm looking outside at this window, that's what that view represents. Now next, we're going to take a look from being inside the house. Here, I just did a little kitchen. Now, when we do orthographic projection, most of the times as designers, we are only doing interior elevations. So this is a little more common for us to look inside a house and then project the lines up at what we're seeing. So it actually is a little bit easier. We're not from the other side. And we'll show you it's just a little bit different, exact same principle though, however. So let's get to that. So if I'm looking at this view, what is this? This is a kitchen. That represents a sink. This represents a stove. This says REF, represents a refrigerator. and DW represents a dishwasher. As I'm looking this way, it's hard because you have to tilt your head here, I project all of these lines straight across. This saves me so much time in measuring and figuring out where the windows are. So as I'm doing this, the difference with interiors is you want to go from inside the wall. When you're doing the exterior over here, you are projecting from the outside of the wall. So, because that's what you see, the outside corners. But when you're inside, you're only seeing from the inside of each wall. So you want to project all your lines from the inside, creating your square footprint. Now, what do you need to know about this? Is what is the ceiling height? Inside this kitchen, the ceiling height is maybe 9 feet. So I have to go 9 feet. This creates my rectangle. Then we get additional information. This is a counter height. Most counter heights are at 36 inches. So we know that we're going to make our counter at 36 inches. What does this dotted line represent? Well, this dotted line represents upper cabinets. So those are represented. Here's an upper cabinet. Here, this dotted line represents another upper cabinet. So you see the upper cabinetry. This is a full pantry. So this is a full pantry. Here's some upper cabs. This is a window. That is represented here, and there's some shiny glass. And then a little sink. So you could see the sink. As we look this way, we are looking at all cabinetries, upper cabinets and lower cabinets. And a little slice right through here. It's like a section. That X means that you sliced through the cabinetry and it's coming towards you. See how if I slice here, this cabinetry is coming towards me. It's an L shape. So it shows that it continues towards you, and it shows just the little profile of the sink. Gives you an indication that this is an L-shaped cabinet. Next, we want to look at this view. So what does this look like? Well, here's a wall that represents the upper cabinets, and it represents the lower cabinets. Also, there's an opening here. That's what that dotted line stands for. There, it opens, walks right through. There's no solid wall, just a walk through. Now we have a stove, and there you see the stove. This is some banks of drawers with some upper cabinets above it. See the little upper cabinets and another upper cabinet and a refrigerator. So that's what you're seeing as you project all of these lines. You're creating that viewpoint. And that's basically orthographic projection. So as you start to see that this could be a tool where you're looking at your floor plan, you're using your floor plan to bring up lines and instantly make walls pretty fast. Now, this won't always be the case because sometimes you have to take a floor plan and scale it up. And in that case, you can't just use your orthographic projection. You have to put your scale down and then double it in size, or vice versa. So if you have an 1/8 inch scale drawing and have to make 1/4 inch elevations, then you're going to have to do it the manual way, and we'll talk about that. But in this case, this is a shortcut way to create elevations and using your floor plan or your plan view. And so this will help you when you're doing a lot of computer work. I can guarantee you that as well. So next, we're going to kind of take a look at the idea of this pictorial image. And so we just kind of talked about orthographic projection when it comes to multi-view drawings, which is this, a plan view, elevations, sections. There's also when you take these images and you slightly tilt them to create a more three-dimensional look. So as you can see, we have 3 different types of ways we draw. We use the projection system for orthographic projection for these multi-view drawings. Then we do something called a axonometric projection and oblique projection. So we're going to talk a little bit about that right now. And this is perspective. You will be taking a semester in perspective, And this is different, and I'm not going to quite get into this just yet, but it's a way of making things look the most realistic. But when you're doing working drawings, we don't use perspectives, only use them to sell the client to show what the finished product will look like. But in our case, we mainly use these more flatter drawings called multi-view, and these two, this axonometric and oblique. So let's go to that. Now, with this multi-view drawings, you always have to realize that when you see one view, you don't know really what it looks like until you start to expand and check out the other sides of anything. That's what it means by multi-view. So you're projecting perpendicular to the picture plane. So this is a side view of an object, right? So as we're taking and we're projecting these lines, we can create a front view, a different view of this object, looking at this way. So if I tilt this object towards me, it's going to look different. This is the side, and that's how we do it. So you have a major face of a form or an object, and that's parallel to the picture plane. So creating this different view, looking this way, it's going to look different. So imagine that little view right there. Once we find out how wide it is, and we pull it using, and this is this face of it. See, it looks like it from one angle. Well, if you just looked at that, you would never know it had a weird, strange angle here. So this is what's the fascinating part about creating three-dimensional type of projects by using orthographic projection and different drawings. So if I just looked at that, it just looks like one square with a rectangle on it. But once I start to project it and show you what it really looks like, look how the entire object comes alive using orthographic projection. Just looking at it straight on, you would never know until you tilt it and give it a three-dimensional look. So these characteristics, they change in size and proportion, and by using orthographic projection, you're able to create a 3D form, and it may vary. So you just don't know. We don't know. That could have been a multitude of different shapes, but it ended up being this one because we had, remember what we had before? We had that side view. Had we not had that side view, we would have never known that this view was that. Because we have this information, we're able to extract this front view and then stretch out the lines to create a three-dimensional object. It's really cool. But there's other things. You know, just having a plan view of something doesn't tell you anything. Check this out. This is just nothing but a rectangle. If I was staring from the sky, looking straight down at this rectangle, it could be anything. It could be this, but it also could be a triangle, and it even could be a curve. You wouldn't know until you had the side elevations. And that's what's so exciting about multi-view drawings, is to see them come alive. When we tilt them a little, we're able to actually create a three-dimensional object. And that's what we call oblique drawings or parallel drawings. When you tilt an object at an angle and you start to bring up lines, now you're creating a three-dimensional look. So there's different characteristics. So different forms have different characteristics, but they might look the exact same from one of the views. So this requires that you need those views to really understand what something looks like. So multi-view images, they can be created from a singular form, but you need additional information. And it's usually the height of something. So here in this case, we needed the height to figure out to make a rectangle. Here, we would have needed one height, let's say is at 4 feet, and the other one is at 0. That tells us it's a triangle. Here, this would show us the radius of part of it, telling me it's an arc. So multi-drawings, the conditions. So alone drawings, they don't tell the full story. This is why we have to create all of the different viewpoints. And that way a drawing can be compared with other views to make sure that it's correct and accurate. and it requires a top view, side and front views, and section views. And we'll go into those, and you are going to do all of these drawings. We're going to work on plan views next week, and we're going to work at various plan views, various exterior elevations, interior elevations, and sections, and axonometrics. So you're going to get a taste of all these multi-view drawings and how a simple image can come alive by using orthographic projection and also understanding how to create multi-view drawings based on the information you're given by me, by the architect or myself. So like it says, when we try to create something a little bit three-dimensional, these multi-view drawing characteristics, there's a significant disadvantage to uncertainty in the depth of flattening them out in their placements. So when we have just a flat drawing, if we can project, we can stretch this out and like project it and elongate it, creating a three-dimensional looking object. And really quick, we're going to talk a little bit about parallel line drawings, which is doing that, which is tilting something and bringing up lines to create a three-dimensional look. And so we call there two different categories on parallel line drawings. There are another form of multi-view drawings, but they're the ones that create the illusion of 3D, and it's super simple to do. And I will be going over that. But in an axonometric projection, you are taking an object, you're putting it at a slight angle or different angles and projecting lines that are vertical, connecting the dots and creating a three-dimensional item. The axonometric projections are based on three different types of angles, but the number one most common is isometric. That's just the perfect, they're both equal. The di meaning two, diametric is two angles that are the same and one that's different. And then the trimetric is three angles that are different. Now, an oblique projection is simple. You just take a plain plan view and you extend lines at a 45-degree angle, and basically you're elongating the item. Or you could take this simple object and rotate it and bring up the lines like I have here. So when you see this square, I just tilted it at a 45-degree angle. I horizontally or vertically brought up lines, and I understand and got the information that this particular block was 4 feet. So I was able to take my scale, put 4 feet, and then once I did 4 feet, 4 feet, and 4 feet, and connected the lines, suddenly this block became three-dimensional the moment I turned it at an angle. See, it's flat, just flat, but the moment you tilt it, it's looking three-dimensional. You see? And now you've got this line and these two angles right here. I gotta do just right. Sorry. See this line? This angle, this angle, this angle, and the other. Suddenly now looks three-dimensional. Before it didn't look three-dimensional until I tilted it. It was just plain at a 45-degree angle. The moment I tilted it, it became like that cube. That's what we can create. It's super simple. Just by knowing this length, we can project these lines down, connect them, and pretty soon we have a three-dimensional square. So that's very much like this situation. Now this is a little bit more the exact object, and we project those lines. Now on this one right here, it's just a little different angle. So another way to do that is using a triangle. It's your 30-60, and you're just tilting it a little different. It's no different, it's just a different angle shift, that's all. So that's one way to do our oblique axonometrics. And just a real quick idea of just showing how you project. And once you have the height, you can connect the dots and create a three-dimensional wonder. We are going to look at that and do a little exercise on Zoom in class. So let me see if I can get to that. So we are going to, just like I did with that square, we have images, we'll project these vertical lines and connect the dots and create something that looks three-dimensional. And like I said, the parallel drawings, there are three different types. ISO, meaning one, there's three axes, they're equal, just one, they're all the same. A diametric drawing means that two of the three of the lines are the same. Dio means two. Trimetric drawings are three axes with three different angles. We're not going to get into that this first half of the class. We're going to do an isometric the second half of the class. But we are going to do a little bit of these oblique angles. And that's basically taking either just the face of something like I just showed you and just drawing out lines and connecting the dots. That's more of an oblique angled drawing. So with that being said, you see that parallel drawings are really pretty simple. They're taking an object and either projecting lines vertically or horizontally and connecting the dots to create a three-dimensional item. And so we see that here. Like I did with my cube just now, I just put the cube at perfect angles. I brought up lines because I knew the height of the cube and I connected the dots. Here, it's just at a slight different angle, like I just showed you on my other rectangle, vertical lines, and you connect the dots. We'll be doing simple objects like this in class so that you can get that understanding of how to take a plan view or an elevation and elongate it to create a three-dimensional object. And we'll work this through together. I promise you it's a lot of fun, and I will see you next time around. Take care.